In this video, I'm going to solve one question from the week 5 homework. It is one of these questions on confidence interval. This is the question. We'll come back to it. And I'm going to solve it in two ways. First, using the definitions of what a confidence interval really is. It's really, once you understand it, not that bad. And then afterwards, I'm going to solve the problem using StatCrunch, and then I'll see that the answers match, and I'll know that I completely understand what it is that we're doing. So here is the statement of the problem, and let's see. We've got a total of 858 births. That's our sample size. And of those 858 births, 425 of them were boys. Okay, super. We're going to construct a 95% confidence interval. So this means that our confidence level is 95%. And that's as far as we're going to read for right now. So let's have a look at what the answer to this part down here would be, because we already know what this answer down here is supposed to look like. Here, I'll tell you. So by the definitions of what a confidence interval is, the answer has got to look like this. This picture down here, this is just a number line. So this is just our number line, right? And I've indicated here this yellow dot, this dot right here on the number line, and I've given it this name, point estimate. Okay, whatever that means. We'll go over that here in a minute. And you can see that on either side of the point estimate, we have this error. So from the point estimate, go this direction by the error, and then go this direction by that same quantity, the error. And where will you arrive? You will arrive right here at the limits, at the edges of our confidence interval. Remember that an interval is just a segment of the real number line. So this segment of the real number line right in here, this is our answer. It's this interval. So it's just, the answer is just the point estimate minus the error and the point estimate plus the error. Super simple. Okay, so up here in the cloud at the top, it says point estimate plus or minus the error. We need to consider both of them, right? And to calculate this number here on the left, the green dot, I would have to take that point estimate, which is the number here in the middle, and then subtract away the error, and you're at that green dot. Or if you take the point estimate and add the error, then you're over here at the other side of our confidence interval. Okay, well, in this problem, being that this is a confidence interval about a proportions problem, the point estimate is this symbol p hat. We'll call this p hat because it's a p and it's wearing a hat. And what is p hat? Well, p hat is just a probability, right? It is just a probability. So in the context of this problem that we were looking at, there was a total of 858 births in that state. And of which 425 of them were boys, right? And I can easily construct my frequency table here. How many of them then would have not been boys? Well, it would have been 433 would have not been boys. And then that adds up to 858 And so right now it's a frequency table. I can convert it to a relative frequency table. This is all like week 1 and week 2 stuff. I can convert it to a relative frequency table just by dividing each of these quantities up here, each of these frequencies, dividing each of these frequencies by the total. If I divide each of these frequencies by the total, then this fraction right here, that is p hat. Because the problem is having us try to make a confidence interval to estimate the proportion of boys. Estimate the proportion of boys. And so when I look at this relative frequency table, the proportion of boys is just the number of boys divided by the number of births. Okay? And this, whatever that number is like the probability of us randomly selecting a boy from all of these 858 births. So what I want to do now is just get a decimal approximation to this p hat out to 4 decimal places. So what I've got here is that this is 0.4953. And we're cool with this being a very small number. Let me say it like this. Isn't that a percentage? I mean, couldn't I say that that's 49.53%? That's one way that you'll know that what you're doing is proportion stats, is that you end up with these proportions, unlike the other kind that you'll do later on in the homework. So this is just number 4. The problems towards the end are a different type. Okay, so we've got p hat, right? The answer, we know this is the answer. It's the point estimate plus or minus the error. All I got to do now is find the error, because I just learned that p hat is this number 0.4953. So whatever my answer looks like, it looks like 0.4953 plus or minus this error. Okay, and then so you'll say, well, what is the error? How do I get that? And I promise to you that the error is easy to find. It's just this product of 2 numbers. It's this number that I'm calling the red number, and then times this other number that I'm calling the green number. So if you can multiply together 2 numbers, you can find the error. All right. Well, that red number is what I want to address first. So the red number, the one that's going right here, traditionally, it really doesn't matter because multiplication is commutative, but we're writing it first in this instance. So that red number is precisely that whatever number that dot has landed on, right? That dot is at the intersection of this edge of this area and the horizontal axis. It's at that intersection. So all that we need to do is put into here, we'll, just like what we were doing in week 4, we're going to insist that this region in here has a specific area, and then backtrack to find out what number that must have been, this red number. And in the problem that we are looking at here, they're saying that the confidence level, remember they asked us for a 95% confidence interval. So this means that our confidence level is 0.95. 95%. So we're saying put 95% of the area right here in the middle of the normal curve. And whatever number that is right there that you get from having 95% of the area in the middle, that will be our red number. And so what I'll do is I'll go to StatCrunch, right? To get to StatCrunch, just you would from your statement of your problem right here, look in the bottom left corner and it says get more help. And when you click get more help, whoops. Well, you can't see it on my screen, but when you click get more help, you can click the option for StatCrunch, and then you'll see a window like this that opens up. And just like what we were doing last week, you can go to Stat, Calculators, Normal. Your normal calculator opens up, and switch it to Between, and tell it that you want 0.95 area in the in-between. And look at how it puts 95% of the area right in the center of this normal curve. And then we can see what that number is. That 1.96 is precisely that number right there, just like what we were describing. Look at how it's almost over the 2, right? So that is at 1.96, that edge right there. And so that's what our red number is going to be. All right, so we have now learned that our red number is 1.96. Okay, halfway done. All we need now is this green number. Well, here it is. Here's how you calculate it, right? Does it look scary? Maybe. But I'm going to encourage you to use the Mathway calculator for the reason that you can type this expression in exactly like it looks right here, and we can avoid the problems of not putting the correct parentheses and stuff when we're trying to use a traditional calculator or even the calculator on your phone. So go to, I just Googled Mathway calculator and clicked the link that came up, and then now I'm going to type into here that formula. So what was it? Well, it's a square root of a fraction. At its heart, this thing is a square root of a fraction. So I'm going to build that structure here in the Mathway calculator. So there's a square root, and where is the fraction button? Here. Okay, so that's a square root of a fraction. And then the number that goes in the bottom is your sample size. And so let me go get what my sample size was. Let's see. I have to refresh my memory. Oh, it was 858. That was our sample size. In fact, let's make a little note. Oh, well, I didn't write it down. So N is our sample size, and that was 858. And now p hat, we got p hat earlier, and I'm going to use the decimal approximation to p hat. We got it as 0.4953. So 0.4953. So if I'm going to calculate that error here, I need these two numbers. So now switching back over to Mathway, then with n being 858, then that's what will go down here. And up in the numerator, well, that quantity it's p hat, so it's 0.4953, but then it's times 1 minus p hat. Okay, so that's the square root of p hat times 1 minus p hat over 858. And I hit enter, and it's supposed to calculate for me the answer. All right, so there I am, 0.017, and then I'll round it to 4 decimal places, 1. So 0.0171. Excellent. I have now learned that my error, or I'm sorry, not my error, this thing, the green number is 0.0171. Approximately. So whatever the product of those two numbers are, that's my error. And typically these have the name, the very complex name of z sub alpha over 2. And I'm not even going to bother telling you why it's called that. You don't even need to know if we use the strategy that I just showed you to find it by calculating the area in the middle. And then this other number is typically called the standard error. And together their product gives us the error for the confidence interval. So then in an expanded form, yes, this is our answer. It's the point estimate plus or minus the error. But then when you answer the question of what all of those things are, then you end up with this formula down here. So this is the definition of a confidence interval. And when you compute the two numbers, right, you have to compute the negative, the point estimate minus the error, and then over here is the point estimate plus the error. So with our point estimate being, I forgot what it was already, 0.4953, then this would be 0.4953 minus that 1.96 times 0.0171. And then that will be the lower edge. That'll be the bottom number for my confidence interval, and the upper one is 0.4953 plus 1.96 times 0.0171. But since I've got Mathway open here, why not just leverage the stuff I've already got typed in to make this thing compute all of that for me. So my point estimate, 0.4953, my point estimate minus 1.96 times that square root, that whatever that computation is going to be right there is going to be the lower limit of my confidence interval. So I'll click the button and there we are, 0.4618. So I'll go back to my problem and it's 0.4618. And they want us rounded to 3 decimal places, so 0.4618 is just 0.462. And then I'll head back over to Mathway, and then I'll just click what I had worked on up here, and I click it, and it comes back in the box. And now I'll just change it to plus, right? So then I'll have the two answers, the point estimate minus the error, and then now here, this will be the point estimate plus the error. And I'm getting that it's 0.529 when you round it. So heading back over to the problem, 0.529. All right, so that's going to be my the limits of my confidence interval. Now I could hit submit and we'd have it. Let's use StatCrunch now just to double check that we've done everything correctly. To find these two numbers, the two numbers that go in these boxes, to find them with StatCrunch, here is how you can get it done. So I'll close this, and if I come over here to stats, proportion stats, remember this is a confidence interval about a proportion. We knew that for a couple of reasons. Number one, that they're talking here about P for proportion. And the other thing that told us it was proportion stats was that, well, let's just rely on that. You see this here in between the edges of the confidence interval. It's a P, then it's proportion stats. If it was a mu, it'd be T stats, but we'll do that later. So here's P for proportion stats, and when I go to StatCrunch, I can click stat proportion stats, one sample with summary. Stat proportion stats, one sample with summary. The number of successes here, well, to us in this, using these words, a success would mean a boy birth. So there was 425 boy births, and out of how many total births, that was 858. So you can already see that this thing is going to it's going to compute a p hat given those two numbers. And since it has, it'll be able to compute p hat. It already knows n, because n is 858. So right there, it's going to have that standard error. And then when you come down here and give it the confidence level, so we'll click confidence interval and tell it that our confidence level is 0.95, then it's going to have that z sub alpha over 2, that red number. So it can calculate the red number, it can calculate the green number, and it can calculate p hat. So it's got everything it needs here to find the limits of that confidence interval. And you can see here that it's getting 0.462 and 0.529. 0.462 and 0.529. So that was what we got back here, 0.462 and 0.529.